All right, so Unit 5, sets and Venn diagrams. This is only focusing on the two set type of Venn diagrams. The other part of this unit is on 3. So we're just focusing on 2 sets right now. All right, so a set is a collection of objects. That's all it is. It's a collection of objects. It can be almost any type of objects, numbers, letters, symbols, people, school, subjects, whatever. It can be anything. So, for example, let's suppose that we call set A the numbers 1, 3, 5, 7, 9. Okay? How we denote that in math, okay, so that's A. We say it like this. So we use these things here called braces, which are just, a grouping symbol. So, we have parentheses, we have brackets, everybody knows those names, and then we have braces. That's the name for those that nobody remembers. In fact, I could never remember myself for most of my first few years teaching. And the number of objects in the set will be written as n parentheses A equals 5. N for number, so it just says the number of things in A is 5. That's all. It's just counting, okay? It's just notation. Sometimes sets can be denoted in words that give a clear meaning of the objects included in the set. So we're going to say B is the states that border Missouri. Okay, so B specifically would be Illinois, Kansas, Tennessee, I'm just going to abbreviate that one, Tenn, Kentucky. If I was better at geography, I would use the abbreviations, but I'm not sure I know all of them. Arkansas, we're just going to abbreviate that, ARC. Nebraska, NEB. Iowa, we'll give all 5 letters there. And Oklahoma. And there's our brace. So the number of sets in B is 1, 2, 3, 4, 5, 6, 7, 8. All right, then we have, and you know this from Algebra 2, we've talked about the empty set before. The empty set is a set with no objects in it. And it's written as either, you can literally just put 2 braces with nothing in it, but you put a space to show it's empty, or we just use the symbol for the empty set, okay? But we don't do both. So you don't put the empty set in the empty set, because then there's something in the empty set. So we don't want to do that. So, for example, the states that border Alaska. Well, that's the empty set, because there are no states that border Alaska. So if you set up a requirement that there's no answer to, the answer is the empty set. So it's kind of like the answer is no answer. The union. If you think about union, it's like when things come together, okay? A legal union, a marital union, the union of the states, whatever. It's 2 things come together. So the union of 2 sets, A and B, is the result of combining the 2 sets together into one larger set. And the symbol is, not too surprising, kind of like a U, capital U is what it really looks for it like. Union notation A, U, B, I'm just going to say U, means the union of set A and B. It includes everything in A and B together. The term union and its symbol will correspond with the word or. So that's important, okay? Because we're saying this or that, which means we're counting everything. So I've said, you've got to be born in a month that has an M in it, or you have to be born in an even month. Well, that would be every month, whether, that starts with M, May, March, and so forth, or an even month, February, April, June, and so forth. Okay, it would include everything. So suppose that set A is these numbers right here, 1, 4, 7, 10, 13. And set B is 2, 4, 6, 8, 10. Well, the union of A and B and I say A and B, even though we're talking about or, it's the union of the two, is the 1, the 2, the 4. Now notice we only write 4 once. We don't have to write 2 4s because it's already in both. And then the 6, the 7, the 8, the 10. And the 10, there's 2 of those, and 13. So we only, for the 4 and the 10, we only write them once. Okay? We don't write 2 of them. It just has to be there in both. Okay? Now, if you notice, if I say the number of A, U, B, just like we did before, we're counting how many there are. So that's 1, 2, 3, 4, 5, 6, 7, 8. It's 8 again. That's the number of items in A. How many were in B? 1, 2, 3, 4, 5. How many were in A? 1, 2, 3, 4, 5. But it's not 10 for the union because remember the 4 and the 10 were doubled up. They were in both. So they only get counted once. So it's really 8, not 10. Let's just put that because it's good to think about. Now, you could also have crazy stuff like here. These are called wingdings. I think that's a technical term for them, like on the computer. They're called wingdings. They're just symbols, okay? So suppose C is that group of symbols, and D is this group of symbols. Hold on for a second. I think the page, yeah. For some reason, my page got screwed up compared to yours. C or D, the group of C, both C and D, would be this. So it'd be the exclamation symbol. It'd be the @ symbol. That's a horrible @ it'd be the pound symbol. It'd be the $sign. It'd be the %. It would be the upside down V. The roof we call in the calculator. The ampersand is a horrible ampersand. The asterisk and the plus sign. And then we put our brace. I'm also very bad at braces. Sometimes they come out okay. Sometimes they come out like deformed 3s. And then we say, what is the number? Remember, N stands for number. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Finally, something that's not 8. There are 9 symbols combined in that set of wingdings. All right, the intersection. The intersection of two sets is the collection of the objects that are in both sets. This is the key word here, both sets at the same time, right? So you've done Venn diagrams before, which is this unit. The intersection is that right there. The middle, the overlapping, the thing they have in common. The symbol for intersection is the upside down U. So the inverted union. So this symbol A upside down U means the intersection of A and set B. And we use and for intersection. Why? Because it's in this set and that set. They're in both. So and kind of goes with the idea of both, which we used above. So it's also the one that repeats. Another word to use, repeats. Okay? Or twins, or matches, or duplicates. They're all the same thing. Common even. These are all terms that mean the same thing. So suppose E is odd numbers up to 12, and F is prime numbers up to 12. Well, that's the verbal description. We want to write the numbers out. Okay? So the numbers are 1, 3, 5, 7, 9, 11, 2, 3, 5, 7, 11. Okay? So what is the intersection, remember this means intersection, of E and F? So that would be the 3 is in both, the 5 is in both, the 7 and the 11. What's the number of items in there? 1, 2, 3, 4. Okay, so next example, G, Group G is red, blue, and green. Group H is white, blue, green, and brown. All right. So what is the intersection, okay, of G and H? So what do they have in common? Well, they both have blue and they both have green. So there's two items in the intersection. Remember, this one means union. So what do they both have? Well, that'd be red. That'd be blue, green. And they both have blue, green. Two E's there. And white. And brown. So red, blue, green, white, and brown, which leads to there being 5 items in that combined union set. Now, the concept of the universal set, that is all possible objects that could be part of the problem. It's the overall set from where they come from. Okay, so we use this, it says scripted, kind of like, cursive, it's not exactly cursive, but it's kind of it's a fancy capital U is what it is. Okay, so if you're doing it yourself, just do something like this, kind of make it a little curvy, whatever. It's just kind of a you want to put a couple little things on there, accents, whatever. It's just basically a fancy capital U. So if A is Missouri, California, New York, then the universal set is what? Well, you're basically saying, what do Missouri, California, and New York, what is in common? What do they have in common is what you're looking for. Well, they're all states. So the 50 states of America, the states of America, the USA, whatever, anything like that. Just something that would be the name of a set that they all came from. So for 9, you got A, D, F, G, M, P, R, Y. Well, what is that called? Well, that would be the alphabet. If you really wanted to be specific, you could say the English alphabet. Don't have to, it would be understood, but it would be a better answer, the English alphabet, because different ones have different letters. Okay. C, blue, green, red. A few different things that you can put there. You could just get away with colors because they are all colors. You could put primary colors. Blue, green, red. I don't know what else you could put, but that would pretty much do it. Colors, primary colors, something like that. Again, that's one of those things where there may not be one right answer. You might be able to come up with something else that fits, and that'd be okay. Now, the complement of a set is all the objects that are not in set A, but still part of the universal set. Okay? So the notation for the complement is A prime. Whoopsie. Oh, come on. Haha. A prime. And we did that in Algebra 2. We talked about in geometry, when you would sketch things, then sketch a rotation or something, we'd say A and A prime, B and B prime. So you've had that before. Okay? Or we can say the complement of A. Okay, but that little symbol, the accent mark, is actually prime. All right, so example 11. If the universal set for U, is that fancy U, positive whole numbers, and set A is evens, then the complement would be, well, positive whole numbers that are not even. So, again, this would be positive whole numbers not even. Now, obviously, you don't write that out. I'm just explaining to you what it is. That's what you have to ask yourself. What is in this set that's not in that set? What's missing, basically? Okay? So if we step back, you don't have to write this, but we step back and we had, these states, and you knew the universal was that, The complement would be the other remaining 47 states. Okay, not that we're going to write all those out, but that would be the complement. It's what's missing from the USA that is not Missouri, California, New York. It's the complement. It's what completes the set. All right, if the universal set is people, okay, and again, this is outdated, so not to offend. It says if set B is female, the complement would be male. And again, it's a very binary, limited view, but this was old, so give it a little leeway, please. All right, if the universal set is the alphabet and C is vowels, then the complement of vowels, in other words, what letters are in the alphabet that are not vowels, that would be consonants. So letters that are not vowels. Okay, now we're going to kind of mix everything up here. So we have the universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9. J is 1, 2, 5, 7, 8. And K is 3, 4, 5, 6, 8. What is J, U, K? So the union of J and K, well, that would be the 1 and the 2. And there's a 3, 4, 5. And there's a 6, 7, 8. So it's all the numbers in J, all the numbers in K. The intersection of J and K, what's common to both of them? That would be 5 and 8. Those are the numbers that are in both J and K. Even for me, that's unacceptable. It's still bad. All right. The complement of J. Now remember, to find the complement, we need to look at the whole list, which is 1 through 9. Look here and say what's missing. So we got 1, 2. We're missing 3. We're missing 4. We have 5. We're missing 6, 7, 8, and 9. So it's 3, 4, 6, 9. What's in the universal set that's not listed in J? What's the complement, okay, K prime, of K? In other words, what's missing from K? So we have 3, 4, 5, 6, 8. So we're missing the 1, we're missing a 2, we have 3, 4, 5, 6, we're missing a 7, and we're also missing a 9 from K. Now, this one's a little tricky. This one, notice, it looks like, oh, J and K. No, it's J complement and K complement. So basically, these two are coming together right there. So what's in both of them, that would be, what's common to both of them is just the 9. Oh, wait, I'm sorry, wait, my bad. It's or, so it's all of them. So we're listing everything in both of them. My bad. So we have, that's a horrible brace, one of my worst. We have the 1, 2, 3, 4. So you have 1, 2, 3, 4. We have a 6, we have a 7, and we have 9. That is the combination of what's in J and K both combined. Now, what's the intersection of those two? What's the only thing common? Simply 9. All right, last one. If you use the alphabet, M is A, B, E, H, K, P, and N is B, C, G, H, J, K, P, T, then what is the number in set M? 1, 2, 3, 4, 5, 6. Remember, we have a little n in front of it. It means number. What's the number in set n? 1, 2, 3, 4, 5, 6, 7, 8. Magic number 8 again. What's the number of M and N both? Okay. So we have to see if there's any repeats. Well, there is a repeat of the B's. Okay, so we're not counting those twice. There's not E. There's a repeat of the H's. There's a repeat of the K and the P. So it's 1, 2, 3, the 8, and then 9, 10, 11. It'd be 11 of them. Huh? Right. Oh, I did mark that. Thank you. It is 10. My bad. I marked it, but then didn't recognize it. It is 10. Clean this up a little bit. Now, the number of the intersection of M and N. What's common? So we just said there was B in both of them. We said there was K in both of them, and P in both of them, and H in both of them. So that means there's 4 common to both. All right, the number in not M. Well, if M is 6, then that's going to be 26 minus 6, which is 20. And the number of not N would be 26 minus 8, which is 18. And that's it.